Hello everyone, today we're going to be doing lesson 31 of module 5. Our objective is I can add mixed numbers. Our objective yesterday was I can add mixed numbers and a fraction. Today we're going to be looking at adding mixed numbers to mixed numbers. So let's get started. First, we would normally have a sprint in class. I'll upload it into Google Classroom so you can get some practice if you'd like. Then we're going to do our fluency here, our warm-up, comparing fractions just like we did yesterday. Using our estimation skills and our knowledge of multiples, we can start with this problem right here. So I'm trying to figure out, is 26 bigger than 25ths? 6 goes into 26, 4, and I have 2 6 left over. 24 sixths is 4, plus 2 more is 26 sixths. 28 fifths is 4. 5 goes into 24 times. 5 times 4 is 20. So 26 sixths is bigger. I'm going to pause here if you'd like to do the rest of the problems on your own. Okay, let's do the rest together. 5 goes into 31. I have 5, 10, 15, 20, 25, 30. That's 6. And to get to 31, I need one more fifth. 6 goes into 24. 6, 12, 18, 24. So that's 4 times exactly. So 6 and 1/5 is bigger. 5 goes into 31 6 times. 4 goes into 28 7 times. 7 times 4 is 28. 8 goes into 65. If I know, I can do my 8s, right? So I got 8, 16, 24, 32, 40, 48, 56, 64. And that's 8 eighths. 8 eighths. And 1 extra eighth. 64 plus 1 is 65. 6 goes into 48. Let's count. So 6, 12, 18, 24, 30, 36, 42, 48. 8 times. My 65 eighths is bigger. 8 goes into 57. We have 8, 16, 24, 32, 40, 48, 56, 7 times with 1/8 left over. 3 goes into 23. I have 3, 6, 9, 12, 15, 18, 21, 7 times, plus 2 more thirds. 7 and 2/3 is bigger than 7 and 1/8. 4 goes into 42. 4 goes into 40 10 times with 2 left over. 3 goes into 30 10 times with 1/3 left over. 2/4 is the same as 1/2, and 1/2 is bigger. So 10 and 2/4 is bigger. Now we're going to do our actual problems for today. Notice our objective is I can add mixed numbers. So both of our numbers that we're adding today have both a whole number, a ones, and a fraction, in this case eighths. So if I want to write this out in unit form, we did this yesterday, I have 2 ones and 1/8. Remember, I'm splitting the ones, the units, from the ones from the fractions. 1/8 plus 1 because the unit form means I include the unit, and 5/8. So that's the expression in unit form. And the units involved, remember the units are our words. So I have ones and eighths. And when we add numbers, we add like units. Just like yesterday, we're going to add our ones first. We got a little bit of practice with this yesterday. First, I add 2 plus 1. I get 3 ones. And if I add 1/8 to 5/8, I get 6/8. Or 3 6/8. I can write it like that as well. want you to take a second and look at this equation right here. It says 2 3/4 plus 3 1/4 equals or is the same as 2 plus 3/4 plus 3 plus 1/4. Think to yourself, is this true or is it false? Take a second. And let's bring it back in 3, 2, 1. So we know from our previous work that this is true, because when we add, we want to add like units. We don't have to write all of this down. Instead, what we can do is we can add the ones first. So this is kind of the step that goes in between, right? When I pull apart the ones from the fractions, but I don't have to write this entire middle step. Instead, what I can write is 2 3/4 plus 3 1/4 equals, and I'm going to rearrange this so that I have my ones next to each other and my fractions next to each other. So that equals 5, 2 plus 3 is 5, and 3/4 plus 1/4 is 4/4. 4/4 is the same as 1, so 5 plus 1 equals 6. So we didn't need to write all of this part down. If we just reorganize it with the whole numbers, that also works. And here's another practice problem. So we do the ones first. I'm going to rewrite it for this one so you can see that process again. First, I pull the ones out. 5 plus 6. And I put the fractions next to each other. 5 plus 6 equals 11. 1/3 plus 2/3 equals 3/3. And I'm still adding that, because technically what I'm doing is I'm kind of grouping these with parentheses. So 5 and 6, these are the ones, and these are my thirds. Now, if my numerator and my denominator matches, I can turn this into a 1. So this is the same as 11 plus 1, which equals 12. Now let's talk about some different methods we can use to solve mixed number addition problems. So first, what do we notice? This is a slightly different problem than the ones we've done before today. So what do we notice about this right away? Take a second. What do you notice about the eighths in this problem? What's going to happen when we add them? Take a second and bring it back in 3, in 2, in 1. The eighths are going to be bigger than 1. The sum of the eighths, 5/8 plus 5/8, will be 10/8. So how I want to show this is I'm going to pull out, just like before, I have 2 5/8 plus 3 5/8. I'm going to pull out the ones, 2 plus 3, and I'm going to pull out the fractions. So in this problem, these are my ones. These are my eighths. Remember from yesterday, I'm trying to make a 1. So I'm trying to make these eighths. I'm trying to pull out an 8/8 so I can add it to my ones. So I have 5 plus 10/8. Now here's our first method for solving a problem like this. I'm going to pull out a 1. We've been practicing this for forever. And 2/8. Remember, these two numbers, the top parts have to add up to 10. Since we're doing addition, the bottom number stays the same for everything. So now I have two smaller addition problems that I can do that make this really easy. This is the same as 1. So 5, because the numerator and the denominator matches. So 5 plus 1 is 6, and then I add on the extra piece. Let's do that again with this example. 2 2/5 plus 2 4/5. I'll write it out with all the steps again. I'm going to group my ones. Remember, ones comes first. I'm actually going to write that right here so I remember. Fractions second. So 2 plus 2, I pull up the ones. These are my ones. And the next part, I'm going to pull out my fractions. And if you notice, just like before, the reason we're going to do this strategy, this number bond, is because when I add these two together, it makes it bigger than 1. So these are my fifths. So 2 plus 2 is 4. I combine my ones. I combine my fifths. Over here, I pull out a 1. I make my numerator match my denominator. And if I pull out 5, I have 1/5 left over. 5 plus 1 is 6/5. Now I add 4 plus 1, that's the same as 5, plus 1/5. I add the extra. I can't just leave that floating. Here's our second way of adding mixed numbers. So in this case, what we can do is we can add the ones first and decompose to make the 1 in the same way we learned to make 10 in the first and second grade. So I'm going to rewrite the problem just so we can see it more clearly and see the whole process from start to finish. Okay, start with my ones. 5 plus 6 equals 11. Now, what we can do here is what I'm doing is I'm pulling the 6 over to meet the 5. So I'm pulling it over to make 11. But I'm going to keep the 5/8 that was with my 5. It's kind of like I'm giving the ones over to here. But this 1, so I'm kind of separating these two. This fraction, 5/8, still stays in that position. It just doesn't have 6 with it anymore. So now what I can do, like yesterday when we tried to make ones, I can pull out the number I need to make 1. So 3 plus 5. If I add 5 and 3, that'll make 8/8. And then I have 2/8 left over that I'll add at the end. So 3/8 and 5/8 will make 1 to add to 11. So 12 plus 2/8. 12 and 2/8. I can also show this with the arrow method. So this is our arrow method. So I have 11 and 5/8. I'm going to give it, remember I'm just taking these pieces that we already worked with, not just pulling numbers out of the air. 3/8, that'll make 12. I'm going to give it 2 more eighths, and that'll make 12 and 2/8. So that's my arrow method. Now let's try it again with this example. So I'm going to rewrite. I'm going to pull out the ones and add them together. So I'm going to give 4 to 3, so I get 7. And I'm going to keep that 7/8 that was already there. I'm just giving the ones over, and I'm separating these two. 3/8 will still stay in the same position with just 4 less. I'm going to pull out what I need, which is 1/8, because I'm trying to make 8/8. I'll have 2/8 left over. So these two come together to make 1 that I can add on to my 7. So I'll get 8, and then I add the extra 2/8 down here. 8 and 2/8. To show that with the arrow method, I'm going to start with the number that I get when I combine my ones. I'm going to add the first number to make a whole number, and I'm going to add the extra. Just like that. Okay, that's the examples of the problems for lesson 31.